into a percentage, then you at least want to have one decimal place for your percent. So rule of thumb, 3 decimal places. Population proportion, sample proportion, this is your X over N. N is how many is in your sample, X is how many said yes or took that choice or whatever it is. We also have to test this because it's not going to tell us it approximates. We have to run 2 tests again to make sure that it passes both of those tests. And if it passes these tests, we know this approximates a normal curve. Again, for our purposes, if it doesn't pass that test, we stop. We just say, can't do it. It does not approximate a normal curve. Most of the time you're going to find they work, otherwise you're not going to have any work to do with that problem. So, most of the time we're going to see that this works. So just a quick little review of what we did yesterday. So we're building our margin of error, and we have a margin of error formula. Again, we use the ZC. We use the p hat and the q hat. Q hat we find by 1 minus p hat. And we use your margin of error. We also said your calculator does a wonderful, wonderful job with this. It's N proportion Z interval. And it prompts you for your X, the lesson, your X and your N. So should they give you a percentage instead of an X, you have to take that percentage of your sample size and find your X. And X has to be a whole number, a discrete number. Because you can't have a partial response or a partial person or anything like that. So you have to make sure that that's a whole number. Pretty much that's what we were looking at yesterday, right? Oh, in the lesson. You were out too, right? Oh, not yesterday. All right, so everybody's okay with this so far? All right, just, yep. I was just kind of going over all the points that we hit yesterday so we can kind of move forward today. All right, so on page 305, we have a graph. And it shows who are the more dangerous drivers. And it gives you a percent for each category. So it's got teenagers at 63%, people over 75 at 33%, and 4% of people surveyed said they had no opinion on who was the worst driver.
Wait. Doesn't that add up?
Does it add up to 100%?
Adds up to 100%.
That's an 100%. 96 plus 4. 100%. But that's a good check because you need to check to make sure your percentages do add up. That's one of the tricks. Remember, we saw circle graphs that were well over 100%, well under 100%. So you have to make sure that you read carefully. Now, we want to set up a confidence interval for 99%. So we want to set up a confidence interval for the proportion of adults who think that teenagers are the most dangerous drivers. So go to your chart, and what is the percentage for teenagers? Look in the graph. Look at the top part, page 306. 63. Okay, I need everybody's attention, guys. So what is your Q hat then? 37. Good. 1 minus your P hat. Your Q hat is 1 minus your P hat. Now, if we use our formulas, we have no problems here. We can set this up. We know your P hat. We know your Q hat. We know your N. What is N? 900. In a survey of 900. Okay. Now, all we need to find is your ZC. So again, this comes from 99% is in the middle, 1% is left over, 0.01 divided by 2, 0.005. If you do inverse norm, let inverse norm do this. And you get 2.575. Thank you. Now just plug these pieces in. He had 63, 37 divided by 900. And you will find your margin of error. So your margin of error turns out to be 0.041. Remember, these are percentages, so that has to be small. It's less than about 4%. So take your p-hat, which is 0.63, plus or minus 0.041. And make sure you leave it, let's do the subtract, do the add, and set it up that way. 0.589 to 671. There's your interval. If you prefer to write it like this, use your population P in the middle, because we can be 99% confident that the proportion of adults that think teenager drivers are the most dangerous for the entire population will fall between 58.9% and 67.1%. If we ask everybody in the United States, we can be confident, 99% confident, that that number would fall between those two numbers. That's why we set up a confidence interval. Now, here's the problem, your calculator. So you go to stat, go to test, you come down for one proportion, z interval. It asks you for an x, an n, and a confidence interval. I forget what they would call that, but 0.99. You know your n, you don't know your x. How do you find x? Where? In your test?
Yeah, I don't know. Like, where does the C go?
Oh, that's your population proportion? Oh, you did a test, not an interval. Don't do a test, do an interval.
So you remember interval.
Interval. How to say INT, you guys are doing Z, you're doing a test. Do the interval one. You don't want a Z test, you want an interval.
Test.
It is,
And then it will say data and stats and goals and stats.
on mine, on the yellow guy, it's A. Guys, on this yellow one, it's A. It's got to say 1 proportion Z interval. Stat test, come down to, on the yellow guy, it's A.
Oh,
One prop. One prop Z INT.
No, it's okay.
Keep going, keep going,
Instead of numbers, it's going to start being letters.
keep going. You need to see 1 proportion. How many proportions?
Yeah, I didn't get it.
Guys, this makes sense if you think about it. How many proportions are we using? 1. We're using a Z-score, and it's an interval, not a test. Test is the next chapter. Hypothesis testing. Teenagers. We didn't finish this. Okay, so now, yes. Good, very good. So we're going to do 900 times 0.63. This is how you find your x. So what'd your x come out to be?
Plus point.
567. This is the guy. You were very close. I need everybody's attention here. This is the one you put in for x. Now here's the problem. It doesn't always turn out to be that nice little number. Sometimes it has a decimal, but you cannot put a decimal in your x. It's a discrete value. When you're asking the number of adults, you can't get a 5.2 adults. You can get 5 or 6, so you have to round. Now, to me, I would round down on this because you didn't hit the higher number yet. So I would round down on this. If you use your rounding rules, that's fine. just show me what you round to, and you know your confidence interval will be a little tiny bit off. In a sample size of 900, it's not going to make that big of a difference. So you put that in your calculator, and it comes back and gives you your interval. Remember again, to find your margin of error, take the higher one and subtract your p-hat. So this gives you your margin of error, should you use your calculator. But make sure you make sense out of this. You're looking for an interval, INT, not a TEST. A Z-test, a T-test, that's different. Interval. And we have one proportion in here, so that makes it a little bit easier. We don't do any true samples, proportions for intervals.
You know how the x is 900 times 0.63.
Because if I say 30% of you guys will go to Penn State next year, 30% of you guys. If I have 30 people in here, how do I figure out exactly how many? I say 30 times 30%, right? We do the same thing. N times the percent, and we figure out the x. Now you notice, if your calculator, once you do the interval thing, it comes back with the p-hat. And it'll come back with this p-hat. So then you know you did it right. If your p-hat comes back differently, then you took the wrong percent. Okay? All right, so you guys do try 3. Okay, this time around, you're constructing a 99% confidence interval for the proportion of people that think, the proportion of adults that think people driving over 75 are the most dangerous. So what's your percentage for your people driving over?
33.
0.33. So what's your Q-hat? Good. What's your N? 900. It's still based on the same survey. Okay. So X is how much? How'd you get that one? Okay, so 900 times your percentage. So Ben came up with an X value in case you're using your calculator. So again, we're going to find your margin of error. You've got all your pieces now. We did the same 99, so we're lucky. We can still use the 2.575. P-hat, Q-hat, over 900. So what did your margin of error come out to be?
0.0013.
So 001?
I got 0.04.
0.04.
0.04. I got 0.04 too. Be careful how you do this. Put it in exactly the way you read it, Darian. Put this in, then you square root sign. Put it in exactly the way you read it. That square root is this whole thing. Okay, so now we're going to build your confidence interval. So your p-hat is 0.33 plus or minus 0.04. So if you subtract 0.04 and you add 0.04, you get your interval. If it's easier to write it this way to help you interpret it, make sure your smaller number is on the left-hand side. So you're going to be 99% confident that your population proportion of the adults that think people over 75 are the most dangerous drivers are going to come between 29% and 37%. If you were able to survey all of the United States based on your sample, that's why your sample has to be really, really strong. A weak sample is a little tougher. Now, if you use your stat test, make sure you are one proportion Z interval. On your yellow calculators, that's A. Your X that Ben told us was 297, and your N is 900, and your confidence interval 99. Again, you can take your high end, you can subtract your p-hat, and you can come up with your margin of error. You do that. Okay? Questions? Easy, right? This one's pretty easy. Yes.
So for this part, the only thing you had to do differently was the E part?
The E. Yeah. Well, your P had changed too. But we had to recalculate your E because your P changed. your P before we did the teenage drivers, we did 63%. This time we did 33% for your over 75 drivers. Okay. And the last thing that we need to do is the same thing we did with your z-scores, finding a minimum sample size. Now, remember the other n we had? We had an n for your z-score 1 for your interval. We didn't have one for your t because that's a small sample, but we do have one for your proportion. Again, you're given the margin of error. Usually that says within 2 people, within 4 sentences, within 1 word. So that's the within thing here. Your ZC depends on your confidence interval, whatever your confidence interval is. And your P hat and Q hat, if they give it to you. Now sometimes, and some of you when you did your polling articles, there were some really nice articles in there if you really read through them, because it had like this concept in there. Sometimes when something's new, you don't have any preliminary information. Like the first time that Obama ran, the first poll that they ever did, they had no preliminary information. So for their P hat and Q hat, like what percentage of the people voted for him? No one voted for him yet. So when you have no preliminaries, you use 50-50, 50%, 50%. If you do have information, it actually gives you a smaller sample size because then you're closer to your population. So if you have no previous information, it's kind of like your population standard deviation versus your sample standard deviation. You can use a P hat and Q hat thing. So we're going to try, and I'll give you that formula. It does come off of your margin of error formula. We just transpose it to come out there. So for instance, you are running a political campaign and you wish to estimate within 95% confidence the proportion of registered voters who will vote for your candidate. You need to be within 3% accuracy of the population. Remember, you did a lot of you did the polling thing within 3%. 3 or 5 is really like the smallest, the better ones they look at. And remember, some of you, if you remember back to your margin of error articles, it caused the overlap to say, well, they're running about the same. If you give me 42% plus or minus 3 and 45% plus or minus 3, if one adds and one subtracts, there's your overlap. So here's your margin of error. Find the minimum sample size. Some of you have a hard time figuring out what this is asking. Find your sample size. If first, no preliminary estimate is there. So this part first says P hat is 0.5, Q hat is 0.5. I have to say 50% say yes, 50% say no. I have no preliminary estimate. So I'm going to plug it into your formula. Okay, so when you plug this guy in, your 95% confidence interval, what's your ZC for 95%? 1.96. So we're just going to plug this in. 0.5 times 0.5, 1.96. There's your margin of error, 3%. How do I write 3% as a decimal? 0.3, not 0.3. And you're going to square that. Again, put this in exactly the way you read this.
Wait, why is 0.03 B?
E is your margin of error because you're doing a proportion. You're doing this. So your proportion, let's say, will be like 0.25.
Yeah.
So this has to be a decimal as well. So we take your 3% and we just turn it into a 0.03. Now, when you do this, exactly the way you read this, the last part is getting squared. And it has the same rule as the last one we did. Round up. Because we don't want to cut it off. We need to get that little extra piece in there. So when we do this, we get 67.11. So we're going to round this one off to 106.8. We need to have a sample size of 1,068 voters registered voters in order to make this valid, to come within 3%. Okay, with no preliminary information. Okay?
Actually, 1,000.
Just around
You have to round up.
Yeah.
Did I write the wrong number down?
Dude, that's
What? What did you get?
How to be 10,068?
It's 1,000.
Yeah, I know. What was it? 1 times 105.
Not point, not 0.05, 0.5, 0.5. That's what's throwing your decimals off.
Oh, jeez.
0.5, 50-50, 50%, 50%.
Oh, man.
Do you know how many kids, when they find out 95% and they subtract to give you 0.5? That happens a lot because you're not thinking decimals. You're just saying, oh, what's the difference? 5 from 95. It happens all the time. Okay, now you have a preliminary estimate. Let's see what happens. So what's your Q hat?
69.
So we're going to find your N. P hat, Q hat. You're going to keep the same exact information. Still your z-score, still your margin of error. Oops. I'm blinking. All you're changing is this, the P hat and the Q hat. Now you have preliminary information. The last poll you ran showed that 31% voted for your candidate.
It's terrible.
It's almost 69%.
No, 31%.
No, but I'm wishing 69%.
Okay, so what do we get here? 13.02. You still have to round this guy up. Now, look at the difference in your sample sizes. Because you know your information, you don't need as large of a sample. You still need a good chunk of people in there because you want to be within 3%. The 3% is guiding that as well. But if you know your preliminary information, you're going to come a little bit less in your sample space. Okay? So again, we have a formula for sample size, and you guys try it yourself 4. You have 8 minutes. You can try it yourself 4. Percent. How do I write within 2%? 0.02. This is your margin of error. Find first the sample size if no preliminary. So first we're going to do P hat and Q hat are 0.5. And we're going to do the rest of this guy. So 0.5, 0.5, 1.645. Guys, hang in there. 0.02 squared. So what'd you get for N?
1691.27.
So we should round it to 1691, right?
Yeah.
We should round this to 1692. Okay? Now, they turned around and said a previous here it is, a previous survey found that 4%. So what's their P hat now? 0.04. What's their Q hat? 0.96. Be careful with the 0.04. Okay, so now you're going to set this up 0.04, 0.96. Same, they didn't change anything else. And what's your N?
259.7.
So we'll round this to 260. Look at how much less we need in here. We need much less in our sample space to be able to do this. Okay, so tomorrow we're going to do a little book exercise.